Everybody, it's Tyler here at the Las Vegas Regional, checking in team number 4415 EPIC Robotz. This team here, winners of the Arizona Valley Regional, of course, here at the Las Vegas Regional, looking to do some great things as well, too. And, of course, we'll be going through this robot here behind the bumpers. And to help me do that, I have Rose, Caleb, Matthew, and Isabella. And I want you to take a look as we start going into this nice compact machine. Their intake has been working great. Their turret over 360 degrees and a great climber all coming up here on behind the bumpers. Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now, supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. If you are planning on attending the World Championship, come meet others in the Fun and FRC Discord community with our combined meetup on Friday, April 22nd at 11 a.m. local. Location will be announced closer to the event, and you can stay updated by following in either the Fun or FRC Discord. Rose, we're going to start out on the intake of your robot here. Talk to me about some of the development process, any iterations, and maybe changes from regional to regional for you.
Oh yeah, definitely. So at very first regional, we had these wheels, kind of squishy green wheels down here, and they were smaller. We also had different Mecanum wheels. We had these more plasticky ones on the outside. That didn't work quite as well for us, so we changed these Mecanum wheels to be much more grippy. We also changed these side arms here to be longer, more extensive, so that it reaches out and over the ball so it can intake much better. We also changed, this is the most recent development, these wheels here we changed to being 4-inch wheels instead of 2-inch wheels. And we sliced off the sides so that way it kind of grips the ball a lot better. And we find that it really claws at the ball and grips and takes it in. And so right now what we have is it programmed to reject the red and come and be able to intake the blue. So we can actually pop it down. So it can actually reject the red ball. So it'll like come back down.
I didn't like that one either, so.
Yeah, and then it'll intake the red one very well. And it's very smooth and it's really easy and it grips the ball really well.
Well, let's keep moving on to your ball transfer system and talk more about what's going into that. So, Coach Caleb here talking about what's happening with these rollers on top.
Yeah, for sure. So, here you go. Thank you. So, once the ball, I'll talk a little bit more first, I think, about the color sensor. So, basically, how we're able to tell which ball that we should intake or not intake is based on our color sensor, which sits right outside of the start of our ball transport here. So, basically, as soon as we've activated our intake, ball will come in, and then as soon as it hits this color sensor, we get data from the FMS that just tells us our team color, and then based on our team color, it'll basically reject a ball, accept a ball, it does that like totally. It's totally automated. It's a totally automated system. Basically, as soon as we've then activated our intake, this bar it's really really good at just gripping these tennis balls or our balls here.
You're looking at the importance of a color sensor on it. Is that like a must-have on your robot, or is that something like a nice-to-have sort of thing?
At the moment, it's more of a must-have because when we're middle of a competition, there are red and blue balls everywhere. It's really, really easy to just run up to a certain section of the field and collect 2 balls of 2 different colors, and so it's really easy for a robot to just pick up the wrong colored ball. Sure, we could probably pick up a different colored ball from the other team and shoot it away, but that wastes a lot of time, really, and it can also take a lot of computation time for the shooter itself. Also, if there's like, let's say, we're blue team, there's 2 blue balls and a red ball, we have to waste a lot of time, again, I think you guys are seeing a theme here, to wait until that second ball has been shot or the incorrect ball has been shot before we can go and collect the correct balls.
Let's keep moving on to your robot.
Yeah,
Let's
sure.
head into your shooter here, which I think Matthew's going to talk a little bit more about that. So I'd love to hear more about this turret that you have here. We talked pre-show a little bit, over 360 degrees, so talk to me more about that. And you got a pretty hefty flywheel on your robot too, so
yes.
Love to hear more about that and how you're compensating for spin on your bot.
All right, so I'm gonna work from the bottom up. So first we have our turntable here. It's actually knife edge bearings with a fitted plate in there. So the plate fits right into the grooves of the knife edge bearings. It gives you a pretty smooth turn. I'm currently fighting the robot. So it spins very smoothly. Right now I'm back driving the motor, so it's not as well, but your knife edge bearing plate runs really well. If we start here, we're able to do one full 360 there, and then we have a little bit of extra room when you spin it all the way around. So it's able to flip in any direction that it wants during the match. With our climber hooks all the way down, our limelight actually clears them, and we can shoot out of any direction of our robot, regardless of the hooks being in the way, which is really nice. For its auto-sensing abilities, we have our odometry, which based off where the robot believes it is, the turret will auto-aim itself towards the center hub, and the odometry gets it in the general area, which then the limelight will take over and give you a much more precise shot. Now for our shots with our flywheels and our rollers up top here, these two actually spin all match long. We have them preheated at all times. When we are loaded with two and our limelight is on target, we can shoot immediately and not have to wait for wheel spin up or any of that. The reason we have flywheels is to maintain that speed all throughout the match, and two, when your ball is shot through your turret, a lot of times your wheel speeds decrease quite a lot, and these heavy flywheels give you the speed on your rotating axle to keep your speed from decreasing so much, meaning that your second shot coming out is much more like your first. The reason why we only have a roller on top is we had previously compression on these balls, and they were being popped out of the shooter rather than spun out by the wheels. And with the different shapes and pressures that these balls are having throughout the competition, our shots were too inconsistent. So with a little bit less compression and our flywheels on there, we've been able to shoot from farther distances and way more consistent shots. And with our 360 and odometry, I don't need to spin the robot anywhere. It auto aims for itself. You pick up two, you stop, and you shoot. And it's been very consistent and very accurate with its fast cycles.
Yeah, looking at your last regional, you guys have been extremely accurate for us. So I can't wait to see you continue to get even more accurate throughout matches as well. Let's wrap up your robot. We're going to hand over to Isabella, who's going to talk about your climber. And I'd love to show up any climber sequences you might have and talking more about what's gone into it.
Yeah, for sure. Okay, so as far as our design goes, we have our pneumatic actuated set of arms, and then we have these spring-loaded arms. These ones just extend up and down, and then these sets just go back and forth. Yeah, sure. I've seen a lot of other teams so far have like pneumatics and extending arms on both of their sets of arms. We kind of just simplified it, and it actually works a lot better than we thought it would. And so far it hasn't failed, so.
So when you're looking at climber concepts on that, how did you land on this climber concept, maybe versus some of the other ones we've seen out there?
Well, we spent about a week just kind of researching different types of climber designs. This was kind of our original design from the beginning. It was something that we really liked. And then as far as this extending arm goes in the first place, it was kind of based off of the Andy Mark design of a climber in the box, but we basically changed it to be fit to our specific robot. And I changed this third stage so that it's no longer a tubing, but instead just this kind of virtual tube idea. And it's cut a lot of weight out for us, which was really nice.
Well, EPIC Robotz, a team that has done so well so far and coming to the Las Vegas Regional. It's a tough regional. We'll see how your team competes, but I got pretty high hopes for you, so I can't wait to see how you do here, and look forward to seeing you hopefully at World Championships as well. Thanks a lot for taking the time. Thanks to Stryker Careers for their support in this video. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.